The brain does not search for truth first. It searches for a story it can survive. Narrative cognition refers to the brain's fundamental mechanism for organizing experience into coherent sequences of cause, meaning, and identity. The human brain does not process reality as isolated data points. Instead, it structures perception through story-like frameworks that link past memory, present input, and anticipated futures. This capacity enables prediction, social coordination, and identity formation. Importantly, narrative cognition precedes analytical reasoning. Before evidence is evaluated, the brain asks whether information fits an existing story. This is why narratives are neurologically efficient but epistemically dangerous. They optimize meaning, not accuracy. Understanding narrative cognition is therefore essential for explain. At the neural level, narrative cognition emerges from coordinated activity between memory systems, emotional valuation circuits, and executive control networks. The hippocampus binds events into temporal sequences, while the limbic system assigns emotional salience, determining which narratives are retained. The prefrontal cortex integrates these elements into explanatory frameworks that guide behavior. Crucially, once a narrative is stabilized, it becomes metabolically efficient for the brain to reuse it rather than reconstruct reality from evidence each time. This efficiency bias explains why narratives, once formed, exhibit strong inertia. From a neuroscience perspective, narratives are not merely stories we tell. They are energy-saving cognitive architectures. Narrative cognition and empirical reasoning operate under different neural priorities. Narrative cognition prioritizes coherence, emotional continuity, and identity protection. Empirical reasoning prioritizes error correction, falsifiability, and probabilistic updating. These systems often compete. When empirical data threatens an established narrative, the brain frequently defends narrative coherence rather than revising belief. This is not a failure of intelligence, but a predictable outcome of neural optimization. Scientific thinking, therefore, requires deliberate cognitive effort to override narrative dominance. Education that ignores this conflict misunderstands the brain. Effective science communication must work with narrative cognition, not against it. Meaning is not discovered by the brain. It is constructed. Narrative cognition is the mechanism through which raw sensory input becomes psychologically meaningful. Events without narrative context are experienced as noise. Through narrative structuring, the brain assigns intention, causality, and moral weight to experience. This process is indispensable for mental health and social functioning. Yet it also creates vulnerability to myths and ideological distortions. Narratives provide existential stability, which is why they are defended even when empirically false. A neuroscientific understanding of narrative cognition reveals that meaning and truth are not synonymous within the brain. The conflict between myths and science is fundamentally a conflict between narrative cognition and error-correcting cognition. Myths succeed because they align with the brain's narrative preferences, simplicity, emotional resonance, and identity affirmation. Science struggles because it demands cognitive discomfort, uncertainty tolerance, and narrative disruption. Until narrative cognition is acknowledged as a primary driver of belief, attempts to replace myths with facts will continue to fail. Advanced neuroscience does not aim to eliminate narrative cognition, but to redesign narratives that are compatible with scientific truth. This is the frontier of cognitive reprogramming and intellectual leadership.